The high plains of Texas only receives 12 to 20 inches of rainfall annually, yet this flat, semi-arid region is one of the most productive crop areas in America with the help of irrigation. In the last half of the century, irrigation has mined the Ogallala Aquifer, making water the limiting factor for most crops. Producers are striving to become more efficient and more profitable with lower inputs, smaller amounts of chemicals, less fuel, and less water.
We have people here that are raising cotton crops on what used to take 24 inches of water on 10 inches of water, 10 to 12 inches of water, and raising as good or better of a crop.
A new irrigation system has been developed on the high plains. It uses much less water, far less energy, and still maintains or increases yields.
Same acres with less water. That's what it amounts to here. We're still watering the same acres, we're just doing it with a lot less water. Probably 25, maybe 30% less water.
More than just hardware, this is an irrigation and tillage management system designed to eliminate evaporation losses. The low-energy precision application or LEPA irrigation systems are very efficient, with 98% of the water getting to the crop even on hot, dry, windy days.
Most of these wells are pumping from 200 to 400 gallons per minute. As you can see, that's very low. So we have to stretch our water out as far as possible. And the LEPA system is approximately 98% efficient in the bubble mode versus 60 to 70% efficient on row irrigation. So as you can see, that's a very huge water saving. And we just use less water and produce same yields on more acres.
In addition to using less water, LEPA saves energy costs by requiring less operating pressure than most conventional center pivots.
My pumping cost, we're figuring they're running from $1 to $1.50 an hour cheaper by using the LEPA system, and that is through, the savings is come about by pumping less water and also by using less pressure, lower pressure, and all that creates lower operating costs.
Crop yields can be maintained or increased while leaving water in the aquifer for future use.
LEPA has added, I feel like 10%, something like that, to yield. But that is not as important to me as we're still making as good a yields but using less water. I feel like that's probably the key for myself.
With LEPA, very limited water supplies can now be considered for center pivot irrigation, allowing the producer to do more with the available water.
Still have a farm that's row watered that just bought this year, and got to get it on a sprinkler to make it pay, I think.
Because I'm marginal on water on my system anyhow. And without the LEPA, I couldn't water what I watered.
LEPA systems are different from conventional systems because the nozzles are lower to the ground, the drops are spaced closer together, and the system operates under much lower pressure. The goal of LEPA is to put the exact amount of water precisely where it is needed.
But we can raise better cotton out under those LEPA systems because we got more control on how much water we get. We don't get 2 inches or 4 inches up at the pipeline and a ½ inch or an inch down on the end of the field. We get an inch all the way through if that's what we want.
LEPA efficiency includes utilizing all of the available water resource, using our irrigation water sparingly, as well as catching and holding rainfall.
We're getting all that water in the ground instead of up on top of the leaves and up in the air and blowing across the fields and stuff. The best example I ever heard of that, some old guy comes up with a glass of water and pours it on your head. How much of that water is going to get in your boot, And take that same glass of water and raise his britches leg up and pour it in that boot. How much of that water is going to go in that boot? That's what I think of these.
Plowing in a circle around a center pivot allows irrigation water to fall precisely into the furrows.
This is plowed in a circle in which we actually use the wheel tracks of the pivot to establish the basis for our row establishment. And we normally start off at every pivot track. We will list the ground and prepare the ground toward the center between the spans. And then as long as we're keying off of that every time on all of our operations, we're always lined up so that these drops are positioned directly in the center of the furrow.
The LEPA system design has drops spaced twice the row width.
if you're buying a system, if you're farming 40-inch rows, you need to buy a system that's on 80 inches. And if you're on 30s, you go to a 60-inch system. And it's real critical to have those drops in those rows, you know, because you get one that's off the side over here, you're missing a row and a half or something, you know, and your water won't make it over there. It won't penetrate that far over. You need to be pretty well on the money when you're in there. I like to see them going right down the center of that furrow. That's where you get your, you know, part of your precision of it, you know, and you do want to be precise on anything you do, especially if you're chemigating or you know, any of that kind of stuff.
Farming in a circle and closer drop spacing together make watering alternate rows possible.
There's another big savings here over just a spray irrigation by the fact that we can confine it to alternate furrows. And as you can see here, our soil surface evaporation loss is really confined to less than 1/2 of the soil surface. So we're cutting our soil surface loss in at least half, and most of the times more than half. So we're really getting nearly every a loss that we normally experience from irrigation eliminated with the LEPA system.
Alternate furrow irrigation allows every plant to be the same distance from a nozzle.
Corn is uniform because you have very little evaporation. It all goes back to the 98% efficient. You have an even distribution of water, and all of that adds up to uniformity.
Another important aspect of farming in a circle is to water the soft furrows.
Always the furrow that you irrigate in has not had any wheel traffic, either the tractor track or the gauge wheel of your plows. So all of these should be positioned every other row. Therefore, when we apply the water, it's in the soft middle, or the one that's not compacted by any wheel track, and that maintains the infiltration rate in that furrow.
To prevent runoff, the soil needs to be ripped or chiseled, have crop residue, or be diked to hold the irrigation water and catch rainfall.
We try to lay by all of our corn with a deep ripper, and that stops most all the runoff, whether it's rainwater or through the sprinkler system. And of course that increases yield, and also it conserves moisture.
Double-ended stocks work particularly well to preserve furrow dikes.
Furrow diking, what we do is we list our land up in a circle, and we furrow dike every other row, and we place our drops in the furrow dikes, and use these drag hoses with a double-ended sock here. And as the water comes out the sock, in order to protect our dikes, it runs out the bottom part of the sock first, and then as it goes over the dike, it runs out the front of it, and it saves the dike, so you don't have to re-dike every time you irrigate. This water goes into the dike, it fills the dike, and it goes right into the ground, right into the plant.
Plowing in a circle, watering soft middles, furrow dikes, and deep tillage are management strategies to uniformly distribute water.
The LEPA system is given a tremendous uniformity throughout the sprinkler system. It doesn't matter if it's rolling hills, sand, clay soils, it doesn't make much difference there.
Because LEPA doles out water to each plant, runoff is not a problem in carefully designed low-pressure systems.
Distributes a magnificently uniform pattern throughout the field. It really does. You get away from that heavy soil moisture profile on the top end of your field as you have in row irrigation, and it distributes the water evenly throughout the field. And if you start detecting a little bit of runoff or a little bit too much water or not enough, you can speed the sprinkler up or slow it down accordingly.
Well, one thing we found out when we converted over to LEPA is you need to run a little bit faster than you did before. I think before the rule of thumb was, you know, you wanted to run your sprinkler slow enough and put down a good amount at one time. And we found that we couldn't hold that much water. So we want to make sure we're holding our water. If we're seeing some runoff like we have this year, then we'll speed them up a little bit more. And at the same time, watch our soil moisture to make sure that we're getting some penetration into the soil.
LEPA systems need less water pressure, so they save energy costs.
Saved about 33% on our overall energy cost from pumping by using the LEPA system.
Because the heads are just 4 to 18 inches above the ground, gravity flow of water from the main pipeline and down the long drops help pressurize the nozzles.
Just the fact that you're not having to spray the water any distance just doesn't require any pressure. If you had an impact sprinkler that was squirting water 30 feet out, it takes a lot of pressure, especially if it's doing it up at the top of the pipe. Down here, you're just wanting the water to dribble out, so no pressure requirement. The pressure we need on this half-mile system is to get water all the way a half a mile down to the other end. And that happens here because there's some 10-inch pipe and some 8-inch pipe and some 6-inch pipe, so this system is running on 26-pound pressure.
With the LEPA, we have some, in fact this one that we're standing at is running on 16 pounds at the pivot, and at the LEPA head it is running on 9 pounds, and so as a rule, most of them at the pivot will run 10 to 15 pounds, which is, at least a third less than others. And that makes it much easier on your wells. Your operating costs are lower. In fact, if you have an existing system, high pressure impact sprinklers, I think whatever it costs to convert it to the LEPA, you can pay for it the first year.
Labor is another cost savings with a center pivot.
Yeah, these systems have taken 40% of the load off on labor. That is for irrigation.
Has that saved you a lot of money?
Yeah, they not only save it, they make it for you.
LEPA systems allow the producer to do more than just irrigate with the center pivot.
There's so many more options with the LEPA system than there is with a regular pivot sprinkler. That it's just unbelievable.
Special LEPA heads have 4 built-in spray configurations for precise water application.
We're using the LEPA head, and that gives us, the option to, spray flat in order to water the crop up if need be. We can put in a bubbler mode, which this is the initial concept with LEPA anyway, just a small bubble to eliminate erosion. Or we can put it in the Accumulation Mode, which will shoot the water upwards, up toward the bottoms of the leaves. That way we can put our insecticides on a lot more effectively.
If double-ended stalks are used for maximum efficiency, they can be popped off and spray pads attached for a flat spray or an angle spray to cumulate up in the crop canopy.
It's in the Accumulation Mode where you're spraying on the underneath side of the leaf, and that's where the insects are. And that's where you can get your chemical down, and it works real good for that.
Various features of LEPA may or may not work satisfactorily on conventional pivot systems. For example, plain drag hoses with no double-ended stalks or special LEPA heads may cause erosion problems. Pressure regulators may be needed in rolling country to deliver consistent low-pressure volumes of water, but no regulators give the system more flexibility.
We have some systems that have them still, but I'm sure happier with the systems that don't have, because it does allow some variation in water flow and keep the pattern even. Allows you to increase your flow if need be, slightly. Just appears to be less problem with stop-ups in general. Just like it better.
Another benefit of LEPA is fewer tillage operations and less compaction of soil.
In saving the trips through the field, you're lessening the compaction of the soil itself. And over the years, I think it's been proven that the more times you cross a field with heavy equipment, the more it's going to compact it, and of course this hinders the uptake of the moisture or whatever.
By monitoring the available moisture in the soil with gypsum blocks or a probe, the producer knows his moisture situation in the root zone and can avoid deep percolation losses.
Moisture blocks are making a bigger presence all the time. However, some people use them for a little while and they only check them once a week, once every 10 days, but the ones that are the most efficient are checking them a couple to 3 times a week, and it makes their operation a lot smoother. They don't have to hurry up and try to catch up. If you get behind in irrigation in the North Plains, you are behind all year, so kind of keeps them on top of it better.
How do you know when to water?
Well, basically, I use these gypsum blocks, and they give you a reading of your underground storage. And we have a reading at 1, 2, and 3 foot depths. You just check the readings there. I just hook up this little instrument, look at it. We look at it about every 3 days, depending on the temperature and the wind.
Producers are watching gypsum blocks rather than their neighbors in determining when to water.
Several years ago, before I started using this, we received about a 2-inch rain, and I shut down and went and talked to Joe Ed Helms, who had these blocks, and he was still watering, and I asked him why, and he said, well, I'll show you, and he showed me his 3 foot level was empty. And I come back over and took a shovel and dug down about 1.5 feet, and I saw why he was watering, because we were dry down there. And so I went back to watering, even though the top foot or so was wet.
Another tool to help manage irrigation is a computer program that calculates ET or evapotranspiration, a combination of evaporation from the soil and transpiration of the plants. This information helps a producer decide when and how much to irrigate.
I keep a daily chart, yeah, with PET and rainfall, and that's how I know how to irrigate. I've got it on my computer, but I run a sheet periodically, so I'll have a current one. This is just the chart for this particular cotton field here, showing the PET at halfway daily, and the frequency of irrigation is on this side where we have the flags, the Y, and the amount of required water and the amount applied. Rainfall is taken into account on that chart. Currently, this circle is running and applying 1 inch, which is what was called for on the 26th.
The amount of irrigation and rainfall should be measured. Record keeping is a vital tool for figuring a water budget and good irrigation management.
You need to know exactly what a well is pumping. Then the other thing is you got to know how much you pumped, and we know we'll know right to practically to the minute exactly how much each well ran on what particular crop they're running on. We know exactly what comes out of each field.
Data on wells and pumping can be very important as a gauge of irrigation efficiency.
We would, figure out how many hours we pumped, convert that to the amount of water we pumped, and then using our yields, determine how many pounds of production or of grain that we produced for every acre inch of water. And we've been keeping that since 1979. Our production is doubled as far as how many pounds that we're producing per acre inch. Several years ago we were producing 450, 500, and now we're up, like Mr. Coleman was saying, 900 to 1,200 pounds per acre inch.
Records can take many forms, from log books to computer entries to maps.
I start with maps that we draw for the farm, and then I just try to keep every operation on a map. It's easier for me in my filing system to know that what's happened historically on that farm, and that way if there's a problem on a particular spot on the field, well, I can pinpoint it on a map. So we keep all our chemical records and all of our cropping records and insecticide and that sort of thing just on maps for our information, and then we do our accounting work as a separate operation altogether. We know how much water we're applying and the time that the wells are running, and so we can pinpoint our cost per day of operation for each well or for each sprinkler, so that we know what the water is costing us. A lot of that detail work is done after the year is done in the winter. We'll spend our winters trying to go back and sort through our maps and our numbers and figure out where we were and what it cost and what we did, so we can know how to budget for the next crop.
In considering the purchase and design of a LEPA system, these target crop production goals are reasonable and obtainable for corn, peanuts, grain sorghum, cotton, and wheat. In designing LEPA systems, the amount of water and the crop are more important aspects than soil type or topography.
So we look at the gallons per minute that we're using and have available to put in a center pivot, which is one of the
key design factors, and the crop are going to be growing. And with LEPA, we've used 6.5 gallons per minute per acre. In other words, if you've got 650 gallons a minute, you could irrigate 100 acres with it. And this is design that we've used for center pivots for corn. With this quantity of water, you can apply about 2.5 inches per week. And this gives you an idea of the number of acres and how much water you can apply to them. In comparison with cotton, we have often used 3 gallons per minute per acre. In other words, if you've got a 120 acre center pivot, you want to be able to design the system for 3 gallons per minute per acre, then you would need 360 gallons per minute to irrigate 120 acres, and this will put down 1 inch a week. We designed the systems pretty similarly for peanuts and cotton. We designed a higher water requirement for corn because it has a higher water requirement. And wheat and sugar beets kind of fit in between. A lot of our wheat and corn are grown in a similar area under similar center pivots. So we can irrigate corn, what we can irrigate corn with, we can do an adequate job with wheat. We use about 5 gallons per minute per acre on sorghum. In other words, if you've got a 500 gallon a minute well, you can irrigate 100 acres with it.
After learning the management strategies of using less water and being more precise with its placement, crop-specific management for LEPA becomes helpful. Early season irrigation promotes root establishment and vigorous plant growth in all crops. Water is especially important for yield increases in wheat to promote tillering about a month after planting. Wheat also needs water when it starts to regrow in the early spring and again after flowering for seed filling to maximize seed size.
Advantage of the LEPA system in production of wheat is over row irrigation, it's about 20% more efficient. So therefore you can use less water or you can grow more crops with less water and still get the same yield and possibly higher yields using the LEPA system on wheat.
The reproductive period of crop development is usually the most damaging time for water stress. In grain sorghum, water use is highest when heads are about 1 inch long just prior to and during booting.
This is a very critical time for water during the boot stage. It's probably the most highest, the usage stage in the life of the grain sorghum.
Grain sorghum responds well to irrigation during pre-boot through heading with yield increases of 500 pounds per acre inch of water.
Grain sorghum's a little bit more forgiving than corn is. You can stress the grain sorghum a little bit more.
In corn, the highest water demand is 2 weeks before and 2 weeks after pollination for higher yields. Adequate soil moisture must be available during the first 4 weeks of grain filling for high volume production.
Up to pollination, we might, stress the corn a little bit more if you want to use that term. We'll let the moisture levels in the soil drop a little bit more. And then as we get into pollination, we'll make sure that, we have all 3 feet filled up. And then as we get out of pollination in cornfield, then we'll start slacking off a little bit more. So we use moisture blocks to gauge our irrigation schedule.
In cotton, water stress during bloom, especially peak bloom, may cause premature cutout, reducing fiber length and yield. Within 7 to 8 weeks after first cotton bloom, pivot irrigation can be terminated to hasten maturity without loss of fiber quality or yield. Cotton responds well to smaller amounts of water applied more frequently, an ideal job for LEPA.
So the frequency in the watering looks like is another thing that's really coming on, especially on this cotton. Like 2/10 and 3/10, and do it something like once or twice a week. Through the summer and stuff. That's no big problem. If you need to get out there and plow, put 2/10 on it, and it'll be dry tomorrow, dry enough to plow, and you can go on. But it's really showing up in the cotton yields. It's the coming thing. It looks like.
LEPA is ideal for spoon feeding fertilizer to crops.
Being able to spoon feed the corn with a fertilizer greatly enhances the yield, and we start about knee-high and go to past pollination, and that greatly increases yield, and it's very effective. Grain sorghum will respond very well under spoon feeding a fertilizer program during its during the summer. It responds very well.
Peanuts are typically grown on sandy soils, making water requirements more critical.
The number of flowers that we have that are fertile will be dependent upon relative humidity. The elongation rate of that peg and the formation of the pod on that peg is enhanced by humidity. So if we can get around quicker on these pivot, if we can water every 2 or 3 days, that's important. If we're losing 40% of our water or even 20% of our water, that's an extra 1 or 2 days to get around. That slows the peanut plant down. So LEPA allows us to go around faster with better utilization of its water. It allows us to hold a higher humidity in there over a constant period of time. This reduces overall water usage 2 ways. It reduces it in evaporation loss, and it shortens the growing season. We can actually get it out in a week or 2 weeks quicker, so we have saved 1 or 2 irrigations on that end. So we've saved water in 2 or 3 different ways with the LEPA irrigation system, and it pays for itself. It pays for itself very quickly.
Once they start blooming and the pegs start going down, then I go to every 3.5 days just to keep a little moisture on that topsoil so those pegs will go in the ground. Because if they meet any resistance, they'll turn and then you've lost that peg. Peanuts load up in September. They'll suck it out of there. They can suck it out of there in a matter of a week or 2. But that's when it's critical once you get your load on. You got to have the water available or they won't mature out and produce a good kernel.
LEPA also benefits crop rotation by allowing a faster change from crop to crop.
The sprinklers themselves actually help us in rotation because it's easier to come in like in the fall. You can plow down your stalks and plant wheat in it and water the crop up and get it going sooner than if you were row irrigating. It just takes so long to water up a crop when you're row irrigating. That's one big advantage to these sprinklers today is that you're able to water up a crop and get it going faster. It sure helps on double cropping, the rotation system. And since I put in this LEPA system, I've just completely quit furrow irrigating. It just seemed to be too expensive per acre fuel cost and to row irrigate, so I just finally decided to just stop row irrigating altogether and just sprinkler irrigate.
LEPA helps in cattle operations as well.
How I generally run my cattle operation, we run cattle on wheat and milo stalks and corn stalks, and sometimes we run them late in the spring, like as late as the middle of April, possibly the 25th of April. By having the sprinkler system, we can pull the cows off at that time, and we can prepare our soil, and we can be planting and watering by the 1st of May. A LEPA system or a sprinkler system is not in operation. I protect the system with electric fence to keep the cattle off.
LEPA allows greater control over water and crop management while saving money for today's producers and water for future generations of producers.
All of the producers now who are getting in the irrigation business, they're in there for one reason, that's to make a profit. And they realize that adding extra water that's unused is just like running water down the Bardage. It's not going to benefit anyone. So as a result, our producers are using less amount of water to grow more cotton.
Oh, LEPA's probably as good a tool that's ever come along as far as irrigation is concerned. It has made a significant difference in the withdrawal from the aquifer and has resulting in lessening the depletion rate.
If you're saving water, you're saving money. You know, your run time on your engines, your labor, everything is reduced by 20 to 25%, as much as 30 and even up to a third of your cost of investment.
Without water resources, agriculture as we know it cannot survive into the next century. Saving water for the next generation is vital.
If you look at the numbers, we're putting on 35% less water than we were when we were row watering, so I feel like we're saving that much water. It'll be there.
The less water that's pumped every year, it's just like money in the bank. They're leaving that for future use. And you know, when you're cutting that back to about 40 to 45% of less water used every year, that's just water you can save for the future.
Extension and Water District personnel have additional information on LEPA irrigation systems.